So we're playing around with compound interest. Compound interest is a kind of percent change, and so pretty much the theme for the rest of this module is percent change. We'll look at percent change in different ways. There's some other examples of percent change that we'll look at besides compound interest later. So depreciation. You buy a new car, immediately loses value as soon as it leaves the lot, and then every year the value of the car drops. Whether you're driving a lot or now. So there's this standard amount that the car drops each year. Some ways of depreciating and accounting, you could say the car drops in value by maybe $2,000 every year, but sometimes they say do a percent depreciation instead. So if we went $2,000 per year, that would be a straight line depreciation. If we do a percent depreciation, that's a curve, like we're playing with the compound interest. So that's what we're going to look at next. Another idea is decay rates. And decay rates happen in a lot of different examples. So for example, suppose you had a whole bunch of chlorine in the pool, you put too much chlorine, so then what you want to do is put more fresh water in the pool and let some water drain out. And so the amount of chlorine in the pool is going to decay because you're diluting it with fresh water. Other example is, anyone ever sore takes a lot of ibuprofen? Ibuprofen doesn't last in your body forever. The effects of it peak and then they start to diminish. And that diminishing effect is usually measured in terms of percentage. So we'll take a lot of that too. Anyone do caffeine here? So caffeine is the same idea as ibuprofen. It has this peak in your body, and then the effects of the caffeine start to wear off because the caffeine gets metabolized in the body. Again, that's a linear decay rate. It's not a linear change, usually it's a percent change. And so those are some problems that we're going to look at in the next few sections. So for now, let's focus on the percent increase, which is our compound interest example. So the formula we came up with the other day was that the amount that we have in the account at any time is going to be based on the initial balance, that's usually called P, times 1 plus the APR raised to the power T. Now just to be clear again about what these mean here, P is the initial amount. This is an equation that's going to come up in this module. R here, I'm referring to the APR, annual percentage rate. And the rate and the time always have to match. So if I'm doing an annual percentage rate, then time has to be in years in this case. That's what I would measure time in if I had a monthly percentage rate. Months, there we go, months. I measure it in months. So that's an important thing here, that the rates and the time have to match in terms of the period that they span. The yearly rate had better be in years. If it's a monthly rate, it better be in months. All right, so with that in mind, we're going to build a spreadsheet using this formula right here, which basically covers question number 2 and question number 3 on your worksheet. So, new spreadsheet. So I've got a couple of different tables here answering question 1 and question 4. We're just going to make one table that can answer any question. So we're going to make a little simpler version of what I have here. So I'm going to start off with a new sheet. In problems like this, we're going to have initial information that we need to keep track of. So before we make our table, we need to put that initial information in. So here, my initial information is going to be my initial balance. That's called P, the principal. So in one cell, I write the principal is, and in the next cell, I put the number. So I'm just going to type 1,000 is what we're starting with. And in a minute, I'll format that as dollars. Other thing that's important here is the rate, R, And that is going to be 2, and I'm actually going to type the percent symbol there. I'm going to go back and click on the principal and tell the computer to format that as dollars, 6, currency format. And then another idea we're going to make a note of here, because it's going to change in the next problem, is what's called the compounding period. And that's something like months or years. So I'm just going to make a note that we are compounding. That means collecting interest yearly. That's just kind of a reminder that my time should be measured in years. So we need to remind ourselves of that every time, otherwise it's easy to mess this up. Okay, so that's my given information. Underneath here, I'm going to skip a row, and then I'm going to start building my table. So in this case, I'm getting interest every year, so I need a column for the years, and I need another column for the balance. I like to put in the starting point. So usually for the starting point, we say like 0 years have gone by, 0 months, whatever. So my starting point, we're just going to leave that blank for now. Actually, no, let's fill it in. What's my starting point here? 1,000. So do I retype 1,000 or do I reuse the number I already typed? Yeah, reuse. So I would just hit equals and then click on where the 1,000 is above. So we never want to retype a number that's on the screen, because if somebody says, ooh, that was supposed to be 1,200, if we do a cell reference instead, it gets updated everywhere. So again, I'll repeat that. For the balance, for the first one, I'm just going to go equals that principal up there. So that's my initial balance. Then I'm going to start building my formula for 1 year and 2 years and so on. I just type a 1 and a 2 under that. And then once you type the 1 and the 2, you can fill that down. And you can fill it down a ways. Go down at least 10 years. We can always extend it farther. And we're going to actually play with this a little bit. All right, so here's we're going to type our balance formula. So here's the easy way. The easy way would be go equals, type the 1,000 instead of clicking on it, times, parentheses, 1 plus, you could just type the rate, 0.02, close parentheses, and then use the shift 6, that caret symbol, to indicate the next thing's a power, and then click on the year to the left. Okay, so that's the easy way to type the formula, but what's the problem with the way I typed it? I type numbers that are already on the screen, right? So it'd be better to click on the 1,000 than click on the 2%. Now here's the problem with that. So just type it this bad way first. Bad but good. And I'm going to hit enter, and then I'm going to fill it down. So again, I'll repeat that in case you missed it. I'm just going to type the 1,000. So I'm using that formula I had written on the board a minute ago. On a spreadsheet, usually you need to type the time symbol, but sometimes it just takes a parentheses at times. 1 plus, my rate is 0.02, 2%, and then hit the caret symbol, shift 6, and then click on the year to the left. Hit enter, fill that down just a few rows, and it's going to make the right calculations. I could format that as dollars and cents. Those are the same numbers we calculated yesterday. Anybody have a question about up to that point? Okay, so let's say type equals 1,000 times 1 plus 0.02 parentheses raised to the power of shift 6. We want to plug in the year. Yeah, so this says take the balance times 1.02 raised to the power of the year. And I'll fill that down a couple of ways. You are not multitasking. Did you fill it down? No. I'm multitasking. How are you guys doing over here? Right? Okay. So check out the formula. In that first year, it was referencing cell A7. And when I filled it down, it now changed that A7 to an A8. Now that's good, isn't it? We want the new year each time. We did something funky. Really fill down that website. Back in 1000. Really fill that. They're still down this time. Okay. So that's good. We want the year to change each time. But if I instead, when I type this formula, if I click on the 1000 times 1 plus, and then click on the rate, raised to the power, I want the A7 to change to an A8, but do I want the balance to shift down from B1 to B2 in the initial amount? Because it's going to try, and also what's my interest rate? Right now my interest rate's in B2. When I fill this formula down, it's going to change the B2 to a B3. That's a problem. So what we need to do is tell the computer to not mess with the 2 in B2 and not mess with the 1 in the B1. And the way you do that is you sneak in front of the 1 for the B1 and you throw a $sign in there. That tells the computer as it reads that cell reference, if somebody fills this up or down, don't change that 1. Why? Because the principal is in row 1. Over here, for the interest rate, is the interest in row 1 or row 2 or row 3? It's in row 2, so I need to tell the computer when I fill this down, don't touch the 2. Put a $sign in front of the 2. If I was going to fill this left and right, then the row letter is going to change. So if I needed to fill this left or right, guess where I would put the $sign? In front of the letter. I say, don't mess with the letter. So the computer reads this formula as you're filling it down, and it says, okay, B, I can change that if you fill left or right. Then it sees the $sign 1. It says, oops, don't screw with the 1. Can't touch it. So now I'm going to hit enter and fill it down and see if it worked. So I'm going to click on that formula, fill it down a few cells, and I get the exact same number. So if I pick the third one here, what I'll see is the B $sign 1 didn't get messed with, the $sign 2 didn't get messed with, but it changed A7 to A9, which is just what I wanted. So that's the difference in what's called an absolute cell reference, $sign says don't mess with me, and a relative cell reference, which means you can be changed when you recopy. So see if you can get that formula in there and fill it down. So your formula should look something like this one right here. So you first make the formula by clicking places. I'd recommend starting and then put the $signs in to say don't mess with a row number. So give it a shot, see if it works. If it doesn't, flag me over and we'll try and fix it. Didn't do much of this before, but this is a super important concept and we're going to use it a lot now. First, just do the new formula without loading up option. You click on A1 and then 3 times. One type it. Now we go back and say, what do we want to change and what do we want to fix? We want the year to change, so we want the principal to be fixed. We don't want to sneak the $sign in front of the 1. Sneak in between B and 2. So that's the question for 1 and this for 2. Oh, sorry, I should have used 2. I'll be one, not A. We put on the word principal instead of, so just change the A. Yeah. now it's got 1,000. That's why I said, fill it down. How's yours, Robert?
I do one.
And the cell. Okay, cool. Yeah, so there's two different ways you can run it. Here's the benefit of running it with the cell references. If later Colt says, well, what if I invested $1,500 instead of 2%? I could just go here and say, well, just replace the principal with 1,500, and then everywhere in the spreadsheet, it immediately gets updated. Colt says, somebody says they'll give me a deal at 3.5%. So you just go and plug in 3.5, enter, and it updates everything below. Okay, so the power of spreadsheets is in cell referencing. And there's two kinds of cell references. Absolute means it can change when you move the formula. A relative, sorry. Absolute means the number you're looking for is always in the same spot. Doesn't change. Okay, we're going to do this again. So so I filled it. I'm going to fill mine down to 10 years. And then I'm going to mess around a little bit. I put a bunch of extra years under 10. I'm going to get rid of those. Now here's the cool thing about the way we typed our formula. I'm going to skip a line under 10. And let's suppose somebody wants to know what's going to happen in 25 years. So I'm just going to type a 25 in that next cell. I mean, two under 10 years, just for fun. And then instead of filling down, I'm just going to do a copy paste. So if I click on my last formula and I do a Control C for copy, and then I click on the new place next to 25, if I do a Control V for paste, it'll automatically paste the right formula in. And now I have a place that's a little bit separate from the others where I can just plug in any year I want. So there's 25 years. Well, what if we did it 20 years? And it'll automatically update. Okay. So again, I'll repeat that. So I just pick a cell where I want the formula to be. And to do that, all I do is click on the formula, Control C to copy, click where I want it to be, Control V for paste. So when we use that magic fill button, that's like copy and paste. And then here I type any number I want, 30 years later, and it'll automatically calculate the value for me. 50 years later, it'll automatically calculate. I'm going to go back and change my principal back to 1,000 and my interest rate to 2%. So now we have a spreadsheet that can answer any question that we asked in the worksheet. So you could label this. This answers, I think, questions like 1 through 7. Oh, except we don't have a graph of it here. Let's do let's repeat this one more time just for fun. So come over a little bit, and we're just going to make a new set of columns for years and balance. And then we're just going to type in the years that were in problem, what was it, problem 5? Problem 4? Okay. Yeah, so we're just going to type 10, 20, 40, 60, 80, and 100. That's the right one. There we go. So 10, 20, 40, 60, 80, 100, something like that. The balance, we're just going to repeat the formula we did earlier. So in year 10 here for the balance, I'm just going to type equals, click on that principal in V1, times, parentheses, 1 plus, click on that rate in V2, close parentheses, raised to the power, click on the year 10 to the left. Do I need to put dollar signs in here anywhere? I need to make a note that the principal is always in year 1. I put a dollar sign in front of the 1 only because I'm just filling down. The interest rate is always in row 2, the dollar sign in front of 2. Formula should look something like this right here. Hit enter, click back over, four down, and we're going to make it back up. 1. Once you get those dollar signs in there, enter, and fill down. So we made this graph on paper the other day. We're going to make it on the computer now and see if it works. So I got a balance of 7,244 in year 100. You all with me? Okay. Highlight all of that information, the words years, the words balance, down to 100, 7,000, and insert a chart. Zoom out a little bit like mine. So a column chart is fine, but we plotted points on our paper, so we could do a scatter plot instead. So you could just leave that one there, that's okay, but I'm going to switch to a scatter plot. And there it is. Now it has a legend for one color. I could get rid of the legend. But it's not a huge deal here. And can we see that doesn't line up? If for this is what's called an exponential model instead of a linear model, and exponential models eventually curve, but sometimes in the short term they can look straight. So maybe those first few points might look almost straight, but it definitely curves after that. If you're not sure about that, you could put a piece of paper to your screen, or remember we can go to series and say add a trend line, and it'll throw a straight line in there. And we can definitely see there, these guys do not line up. Here's a cool trick on that. Scroll down on trend line. Notice the type says linear. Click on the other types. Is there one there that might fit what we're doing here? Yeah, exponential. So I'm not going to explain their exponential model now. So I'm going to put the label up just to show it. So they say it's 1000 e raised to the power 0.0198 times x. So I'm not ready to explain what that means today, but I'll get to that probably mid next week. So we don't need to put a model on this. I just wanted to show if I tried to put a straight line, it's definitely not straight. And there was a question on your worksheet that says, hey, is this straight or not? I'm going to turn that trend line off. And we got it. So for questions 1 through 8, as far as the spreadsheet goes, oops, that's covering up the stuff. What I wanted you to do is get used to using a formula with absolute and relative cell references to make those calculations. So we got that here and here, and then we reproduce that table. So let's try and do question number 8 now. So before I bring it to the spreadsheet, I'm going to bring it to a piece of paper. All right, I'm going to copy this information right there. So in a minute, we're going to put this into a spreadsheet. Some days I go straight to a spreadsheet to do my work, but that's typically only if I've already done it before and I know what I'm doing. So usually before I hit a spreadsheet, I'm scribbling stuff on paper to try and figure out what the heck I'm going to do in the spreadsheet. So just a couple things to keep in mind here. We have a formula. This is number 8, yeah. To calculate an amount based on a rate and time for compound interest. And it looks like this. The amount equals P times, parentheses, 1 plus the rate raised to some time period. And I mentioned earlier a really important thing about the rate compared to the time period. Anybody remember what the important thing about those two is? They have to match in terms of time. Okay? So if we want to do time in years, then the rate has to be a yearly rate. If we want to do time in months, then the rate has to be a monthly rate. So R and T have to be over the same time period. Now that's more important here because the catch in this one right here is that we're putting stuff in account where we get interest every month. So we're now shifting the time period. So they're telling us that since we're compounding monthly, T has to be measured in months. What kind of rate did they give us though? What's that? They give us an annual rate. Yeah, so I have to convert that annual rate to a monthly rate. So right now I have an annual rate of 2.4%. What I really need now for my formula is a monthly rate to match the time period I was given. So how do I calculate a monthly rate based on that? Yeah, just divide by 12. So I'm going to take that rate right here, 2.4%. I'm going to divide it by 12. Now sometimes this number is missed, in which case I want the spreadsheet to do it. So you get these really long, crazy decimals. In this case, it's not too bad. I think we get what, 0.5%? Is that right? So I'm going to have my spreadsheet do all of that. But this number right here, that's actually my R, not the 2.4. And T is going to go every month instead of every week. So my spreadsheet's going to be similar, but different. 0.02, did I not do it right? Okay, I messed that up. With my calculator, I take 2.4 and divide by 12. Oh yeah, I was wrong. We get 0.2%, not 0.5%. Thank you. All right, so 0.2% is my new percentage. So again, I'm going to have the spreadsheet confirm that for me, just like Jenna helped with the calculator there. So back to the spreadsheet, let's make a new tab. Part 8. So I'm just going to put my initial information here, my principal. What were we given for the principal? What is it? Was it 1,000? I thought they gave us a different number. It is 1,000? Okay. Then I'm going to put my APR in here. And that's the 2.4%. And then underneath that, I'm going to put the compounding like I did before to remind myself that I have to do things monthly, not yearly. And so now I'm going to put the monthly rate in next. And so to do that, I'm going to use cell references. So I'm going to just go equals, take that 2.4% and divide it by 12. And the computer says it's 0.002. Does that look right? 0.2%. I think that's right. It's showing me an extra decimal place. That's okay. If you don't like that, you can always decrease the amount of decimals you see. So under that, I'm going to set up my table once I have the initial information. I've got months, and I've got balance. So on that one right there, what I did was I started off with a calculation, and I wanted the computer to check for me. If I take the APR and divide it by 12, do I get the right rate that we calculated before? So even though sometimes it might look like a calculator to do stuff, a spreadsheet is a calculator. So we should always have it do the calculations on the screen. All right, for months, we're just going to go 0 and then 1. Oh, did you times 12 by mistake? Oh, so okay. So click on monthly rate is just click on the APR. Equals. APR. And then this time we're going to start the formula next to month 0. formula is going to look almost like the formula before, but just grabbing the rate from a different spot. So I have to start off with an equals, click on my principal. Computer expects us to hit times next, and then the parentheses. 1 plus, which rate do I want? The monthly rate, yep. Close your parentheses, raise it to the power, whatever the number of months to the left is. Now, are there any of these that are fixed? Is the principal fixed, or does that change each month? Principal is the initial amount, that's fixed. I need to fix that in row 1 by doing a $sign before the 1. The rate the same, or is it fixed? It's fixed, so we need to go before that 4 and put a $sign there. Do the number of months change, or are they fixed? Change, yeah, 1 month, 2 months, 3 months, so no $sign for the months. So it should look something like that. Let me blow it up again. Put things in the same cells as me. Principal is fixed, it gets a $sign by the 1. Only the 1 because I'm filling it down. Rate is fixed, it's in row 4. All right, hit enter, fill it down a few cells. So a couple things to fix. I don't have a currency format. I probably should fix that. So click on currency format. And then I can fill a whole bunch of stuff at once by highlighting 2 rows at a time and then filling that whole group down. And I can go as far down as you want. So we'll repeat that just for fun. And hopefully you're getting, like in year 4, I got $1,008.02. All right, so they had 1 month, 2 months, 3 months, 6 months, 12 months, 24 months. So we can easily change our thing into an amount calculator by just tweaking it a little bit. So what I'm going to do is I'm just going to do the first 12 months and get rid of the extra stuff. And I'm just picking 12 months because it's a year. I did a whole bunch of extra ones. And then I'm going to skip a line under 12 months, and I'm going to give myself a place to type any number of months that I want. So for example, I'm going to put a 24, and then I'm going to copy and paste my formula into the cell to the right. Control C to copy, Control V to paste. So there's 24 months. If somebody wants to know the value in 36 months, I just replace the 24 with 36, and it updates automatically. Sounds all right. All right, anybody else have a question on this one? Okay, so take a look at your worksheet, see what questions you need to answer on this. And then eventually you're either going to put a shareable link in Canvas for this, or if you did it in Excel, you'll upload your file to Canvas. Take a stab at what that general formula is for 9, and then we'll compare notes on that before you turn it in. And 10 is going to require a little bit of work. Anybody ready for question number 9? So 9 says, what's a general formula for compound interest? So I'm calculating a new amount, so that's what we call A. I have to have the principal, that's the initial amount. I have to have an interest rate. Typically, we're given an APR. It doesn't matter whether they're doing it monthly or yearly, every other year, every 5 years. Every bank's going to give you an APR, annual percentage rate. And then generally we do time in years, even if it's compounding monthly. So the other thing I'm missing here from my formula is something to tell me how often to compound. So there's another variable that gets thrown in here. I'm going to call it N. N is the compounding period. Number of times per year we get interest. Principal, remember that's the initial amounts, the initial investments. APR is annual percentage rates. All right, so here's what the formula is going to look like. Not too much different than before. We're going to have A equals because we're trying to find that new amount. What's the first thing we need for our formula? Principal, yeah. So we take the principal. And then we have to multiply that principal by our growth multiplier. And that's always 1 plus something. Yeah, so it's the APR only if we're compounding every year. What if we're not compounding every year? What do we do to the APR? If we divide it by 12, but maybe somebody's collecting interest every day. What do they divide by then? 365, yeah, so that's what N is. N is the amount of times per year you get more money. It could be 12, it could be 365. There's some accounts that pay out weekly, right? So then N would be 52. So what we do is to calculate the rate we add on, it's always the APR divided by the number of times per year you get interest. Now, this is now what's called a periodic rate. So to get the number of periods to raise this to power, we have to take the number of years, but then we have to multiply by, was it 12 times a year, was it 365 times a year, or was it 52 times a year? So it's T times N is the power. And usually, to be careful, I put that in parentheses because it's complicated. So this is called the general compound interest formula. And it deals with yearly compounding, N would be 1, no big deal. Monthly compounding, N would be 12. And we made a spreadsheet formula that does this a couple of different times, but this is the general way it looks on paper. All right, one more question to answer, and then we're out of time for fun with math today. Compare the return on a CD with an annual compounding that pays 2% and one that pays 4% interest. Are the returns double? Right, so we're getting twice as much interest, right? Do I end up with twice as much money or not? So we're just going to build a table and take a look at that for number 10. So we're going to compare 2% with 4%. So new spreadsheet tab, part 10. It's always a good idea to label your sheets so you can look back at them later and know what the heck's going on. Title at the top says lesson 4.1. I have a tab down here says part 10. So I don't think I need a bunch of initial information. I'm just going to put years on one side. I'm going to put balance at 2% in one column. In the next column, I'll just put the balance at 4%. I just want to compare, see what the money looks like for each one of these over time. I like to do a 0 year just to get things started and then go 1, 2, and so on. So they said to compound yearly, but just change the interest rate. How much money do you guys want to start with? $10? Okay, $10 it is. Oops. So I got to go equals 10. So now I'm just going to fill in my formula. Times parentheses. This one's going to be 1 plus 0.02 for 2%. Close parentheses and then raise it to the year here. So we're not going to worry about cell references except for the year here. Keep it simple. Enter. Fill it down a couple. Yeah, and then I'm going to show dollars and cents there. So for this one right here, it's going to be equals. Colt said let's start off with $10. That's our principal, times parentheses. And our formula says to always take 1 plus the rate. What's the rate here? 2%, so I type 0.02 for 2%. Close the parentheses, raise it to the power, number of years to the left. And then fill that down a few. Because the writing will screw it up. Yeah, the only way it would work is if I made a table like before where I said the rate equals 2%, or the other rate equals 4%. So if we wanted to play with different rates, we would definitely do it that way. But I just wanted to do this one quick and dirty. Yeah. Yeah, so we want to do the same thing for the 4%, and then just fill it down a ways and see if we can answer the question that they asked. Working. Raise to the power. Oh, yeah, well, you put it in there. And plus, here the rate is 4%, raised to the power number of years to the left. And then fill that sucker down. And then grab a whole group of them and fill them down a ways. And I can grab this whole block here, fill it down. It looks like I missed dollars and cents there. All right, so let's see. What's the question again? The question says, we got 2% versus 4%. Are the returns doubled? So the return is what we make over 10 bucks. Okay. So let's take a look, pick some random year there. So I'm going to pick year 17. In year 17 on the 2%, I made what, 4 bucks? What's double 4? 8. How much did I make on 4%? I made $9.48. Oh, more than that. The reason is the extra interest is collecting more interest. Yeah, so that's the thing about compound interest. Doubling the rate more than doubles your money over time, because the extra interest you collected in the beginning is collecting interest. And the extra interest you collect in year 2, that's going to collect even more interest. So over time, you'll do a little more than double 2% versus 4%. The compound interest is a really powerful thing. And I'm going to continue to play with this for most of this month. All right. So make sure you get that share link and drop it into the Canvas assignment eventually. It wouldn't hurt to share this with me too directly by email address. Hopefully you have my email address saved in there. Good idea when you share something is to put a little note in there too. If you're done with the worksheet, feel free to turn it in now.